you'll see that the quadratic is in this form, right? And not the ax squared plus bx plus c, and not the form that you can actually read the vertex in. So when the equation of a quadratic function is in general form, y equals ax squared plus bx plus c, most characteristics of the graph cannot be identified, such as the vertex. The only thing you can really see in that form is what? Really easy. When it's in that form. Huh? The y-intercept you can see really easy, right? Because then all these x's go to 0 and the y is just that constant. But that's the only thing you can really see really easy. So rewriting y equals ax squared plus bx plus c into the form y equals ax minus p squared plus q can be done in order to determine its characteristics. This can be done by what's called completing the square. Recall. Does anybody remember what this polynomial was called from grade 10? I'll be very impressed if you remember, actually. It is a so this is, okay, so now I need to know what the first two. Trinomial is right. No, not binomial. When it factors, can anybody factor this really nicely? It's actually x plus 3 times x plus 3, which is x plus 3 the whole thing squared. Yes, it is called a perfect square trinomial, because when you factor it, you get what's called a perfect square, right? And some of you never ever used that shortcut when you did it in grade 10. If you can see that the square root of 9 and this is double that, that's the perfect square trinomial, right? And it automatically goes into that. So let's see if you can figure out what would k have to be in order for this to be a perfect square trinomial. I hear 16. 16 is absolutely correct. If this was x squared minus 8x plus 16, what would that factor to be? X what for? Minus or plus 4? Yeah, it would be x minus 4. Okay, how about this one? What would k have to be a perfect square trinomial? Huh? I hear 25, that's not correct. Well, I hear Ness saying something here. Say it. 2.5 squared. So would that be what? What would that be? What's 2.5 squared? What's 25 squared? Yeah, 6.25? Okay, so if you, the person that got 16, how did you get 16? $16 squared was 4 times 4, and 4 plus 4 is 8. So that's how you got it. Okay, so if that logic holds, you kind of just went out there and got the 16, right? Yeah. Okay, so now, how did Ness get 6.25? Okay, you're close when you said half it, then you double it. If you half minus 8, you get 4, and you square it, you get 16. So this is how I assume Ness got this. He halved 5, and he got 2.5, and then he squared it to get 6.25. So then what is this factored to be if this, oh, I should write it like this. x squared minus 5x plus 6.25. What is that factored to be? What is that factored to be? Yes, x minus 2.5. Okay, so I'm going to actually go through. So how did we determine this number? We took the middle term, right, and divided by 2. I should say the coefficient of the middle term, right? And we divided by 2, and then we squared it. It says took middle term coefficient divided by 2, and then we squared it to get that. Well, let's look at the one before. If we take half of 6, we get 3, and we square it, we get the 9. Do you see how it works? Okay, so this is what's called completing the square. So what I wrote over here again was took middle term coefficient and divide by 2, and then I squared it. Okay, so the first term, step in the method is to rewrite the first two terms together and leave a little bit of space between writing the constant term. So I'm going to write it like this. Y equals 2x squared minus 12x. Leave a space plus 11. What's going to happen here is I need to figure out what this k is, and that's why I'm leaving a space. Does everybody see? When I go back over here, this part of it is going to be the part of the vertex for the x, right? And then the stuff on the other side over here, that's going to be your y of your vertex. Oh, you're seeing how this is going here. Well, it'll take a little bit. I warned you this is going to be difficult. Okay, so the second step is we can't, in all the ones we did before, we didn't have a coefficient of x squared. The coefficient of x squared has to be taken out. The only way we can do that and still have the same equation is by factoring that coefficient out. So I need to factor the 2 out of the x squared. But I also have to factor it out of that middle term. So this is now going to become minus 6x. I'm going to put the bracket like this. Leave a space, right? Plus 11. Okay. Just verify this step. If I were to multiply the 2 out, I would get exactly the same that I started with. Does everybody agree? I haven't changed the equation at all. If I were to multiply the 2 in, I would get what I started with. Yes, I haven't changed anything. Because you can't just do stuff to equations unless you do it to both sides. But essentially what we're doing is we're changing the right side. So whatever I do the right side, I got to make sure it's all legit. So if I multiply this all out, I'll still get back to 2x squared minus 12x plus 11. So now, you need to figure out the square of half the middle term. This is where we're completing the square now. So we take half of that minus 6, so that's minus 3, and we're going to square it. And what we're going to do there is we're going to put that in right there. Okay? So now you might be saying, whoa, 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 whoa. If I multiply this out right now, I've now changed it. You can't just throw a 9 in there. Actually, what I threw in there wasn't a 9. It was really a... It's actually 18 that I actually put in there, right? Ah. Okay, so I can't just add 18 to the right side and say, I made it into a new question. No, you can't. So you remember back in grade, I don't know, 8 or 9, you started with algebra and stuff? And say you had a, I don't know, x plus 2, and you had a, I don't know, a 9 over here. And this part of it, have you ever seen this part? It's like a balance thing. This is a teeter-totter. So the way teeter-totters work, if you've ever been on it, if somebody goes on this side and makes it heavier, what happens? It goes down, right? Yeah?
Yeah.
And then that goes back up. Yes? So for instance, if I want to get rid of the 2 and I say, I'm going to subtract 2, I'm just going to get rid of it. What happens? The teeter-totter goes like this, and it's not balanced anymore. So how do I actually balance it? I got to get it back to being balanced by taking 2 out of this 9 and get 7. So do you see x is 7 and it's back to balancing? Okay, so the same thing kind of analogy works here. I added 18 right there. So how would I get rid of that? I could add 18 to y, but then that's not really the form I want. I don't want 18 plus y, I just want y. So what's the same thing as adding 18 to the left-hand side? Subtracting 18 right here. Does everybody see? If I add 18 and subtract 18, I haven't actually changed the question. Well, because I can't just add 18 and say it's the same question. Because I'm trying to make that perfect square trinomial. So if I go back over here, remember what I was doing? I was taking half the middle term and squaring it and putting it in there to get this perfect square trinomial. So that's what I'm trying to do here. So add step 3's answer right after the first 2 terms. That's what I just did. And subtract to the right side of the constant. Be careful of the coefficients. That's why I'm saying a lot of people will make a mistake and they think they're adding 9, but you have to watch for the coefficient that you added out. That's what I'm trying to say there. The 2 and the 9 was really adding 18, so now I'm going to be subtracting. This step works because adding and subtracting the same terms what each other? Cancel each other. Does everybody see that? I haven't changed it. Really, by adding 18 and subtracting 18, I haven't actually changed the equation. So now we're going to factor this trinomial, and hopefully everybody's good at factoring that trinomial. What would this be factored into? What would this part right here be factored into? X minus 3, very good. And then we can't forget about our constant there. What happens when we simplify positive 11 and minus 18? We get minus what? 7. So does everybody see? Now I can actually see the vertex. It's a lot of steps, and it's very algebraic. So at some point, you just have to keep on doing and practicing to get it right. Okay, let's keep going here. Okay, so first step is write it with a space. Oh, I got it big there. Hold on. Okay, the second step is making sure that the coefficient is factored out of the x squared. In this case, we're just going to be practicing the first 2 examples without the coefficient, so we don't have to worry about that. So, does everybody see there isn't a coefficient, so that step where I have to factor out, I don't have to worry about it. Okay? So the next step is to take half of the middle term. What is that? Minus 2, and square it and put it and add it right here. So plus 4. But in order to do that, I need to subtract 4 here. Does everybody see what I'm doing? Now it's this part that ends up being the perfect square trinomial, right? And what is that when it becomes a perfect square trinomial? What squared? X minus 2 squared, and what's 12 minus 4? 8. Y equals x squared minus 6x, leave a space, plus 2. Sometimes we see this put into brackets in different textbooks. It's up to you if that helps or not. Okay, so half of minus 6 is minus 3. So some of you, if you're getting good at this, you'll go, oh, minus 3. So I'm going to put that there right now so I don't forget. Oh. Right? Now I'm going to square it, plus 9 minus 9. Oh. Do you see what I did there? And then last step, I need to, this, of course, becomes that part. And what does this simplify to be? Minus 7. Okay, we're going to do this one together because this is now with the coefficient. So I would, instead of writing the same thing over with a space, well, maybe in this one I'll do it. Okay, I'll show them. Okay, so I left a space. Does everybody see there is this 2 that is not going to help us complete this square? So we got to factor it out. Factor it out. So y equals 2 bracket x squared plus, what does that become? 2x. You guys are good so far. Okay, if you want, you can put the end of the bracket with a space, minus 9. Okay, does everybody see what I did? It's exactly the same thing, except I factored out the 2. So it's 1, yes. So this is going to be half of 2 is 1, so this is going to be x plus 1, the whole thing squared. And if I square 1, I actually get 1. But what do I end up subtracting, though? No. This is actually 1 times 2. So I actually have to subtract 2, which makes 11 this time. So that's why I'm saying you got to watch, because you have to watch this coefficient is affecting this. So not only are you adding 1, you're adding 2 times 1, which means you have to subtract 2 times 1. Okay? So what happened here when we had the coefficient? That means there was a vertical stretch with this vertex, yes? Do you see where we're going with this? We're going to graph these babies after. Well, we know how to graph them. This is just a base. This is just a base graph that got stretched double, moved to the left 1, and down 11. We know how to do that. You did it for homework last night. Okay. Y equals negative x squared plus 8x, leave a space, minus 3. Is there a coefficient I got to worry about? Oh yeah, that's a coefficient. That's negative 1 in there. I don't usually write the negative, but we do have to factor it out. So negative bracket, we get x squared. What does the 8x become? Negative. It is negative 8x now. Well, watch. If I multiply this out, I have to get a positive 8x. So a negative times a negative 8x gives me positive 8x, right? Gotta watch. Okay, now we're doing half of minus 8. What is that? What's half of minus 8? Minus 4. If I square it, what do I get? A plus 16. But really, what did I actually just do there? I actually minus the 16 if you look at it. So what do I have to do to compensate? I need to add 16. So then what's negative 3 plus 16? Plus 13. Okay, I saw a couple people color code things, so I think I'm going to try that in the next one here. Okay, so y equals, I'm factoring out a negative 2, x squared, negative 2 times what gives me plus 10x? A minus 5x. Leave a space, plus 3. Now, at this step, this is where people are making a mistake. So I would say in the first step, multiply it back. Do you get where you started with? Watch. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 5x is positive 10x, you see? And then I just have the token plus 3 at the end out of the brackets, right? You have to do that step because that's where you're going to start the mistake and then you do the rest of it wrong, right? Okay, so now I'm going to do half of minus 5, and we already know that from the previous one. Half of minus 5 is 2.5 squared is 6.25. Oh, this is where I was going to actually do the different color. This is what I saw somebody do, and I thought that was brilliant. Plus 6.25. But remember, this is those two together, right? So what is minus 2 times 6.25? Minus 12.5. So I just subtracted 12.5, which means I need to add 12.5 here, which gives me plus 15.5. So who got that one right? Not a lot. That was a hard one. That was a hard one. The next one's another hard one. When I factor out the negative a quarter, most people are making a mistake because they don't know how to factor out. So again, negative a quarter times x squared is negative 1/4 x squared. What's negative a quarter times what gives me negative 4x? And it's not x, because negative a quarter times x is negative a quarter x. It's actually 16x. Try that again. Negative a quarter times 16 is 4, right? With a minus. Essentially, when you factor, you're dividing. When you're dividing a quarter, that's the same as multiplying 4 over 1. Do you see that? So if I'm multiplying 4 over 1 to 4, I get 16. Okay, so then next step, negative a quarter, x, what's half of 16? Plus 8. If I square that, I get plus 6. Oh, I was going to do this in a different color pen. So I'm going to do plus 64. Plus 64, but again, this is not really adding 64. I'm actually subtracting what? 16, which means I add 16 there. So minus 18 plus 16 is minus 2. Who got that one right? 2 people got it. 3 people got it right. 4 people got it right. Okay. Next one's a little easier. We throw a couple easy ones once in a while. Did you get a chance to do the next one? No. Okay, I will give you a chance. Next question. I'm going to factor out the 3 to both terms. Leave a space, minus 1. Did everybody see what I did? I factored out the 3. Yes? Okay, so far so good. I'm taking half of positive 2. What's that? Plus 1. I'm squaring it, so I'm adding 1. But really, I'm not adding 1. I'm adding 3 to it. So I need to subtract 3. So my final answer is that. Okay, next one. Y equals negative 2 bracket x squared. If I factor the minus 2 to the middle term, it's going to be minus 3x. Did everybody get that in their first line? Yeah. Okay, so now I have to take half of minus 3. What's half of minus 3? Minus 1.5. If I square 1.5, that is 2.25 times minus 2. So that is actually negative 4.5. So I actually subtracted 4.5, so I need to add 4.5. So what do I get? Negative 5.5. Everybody agree? Yes? Okay, moving on. The fraction ones. We love the fraction ones. Let's factor out negative a half. Okay, so when I'm factoring, that's the same as dividing by negative a half. The same as dividing by negative half is multiplying by negative 2 to this term. So what do I get? Minus 4x. Multiply this out and see if you get what you started with at that step. If you've confirmed it, you did it right. So now we're going to take half of minus 4. What is that? Minus 2. Squaring is plus 4. But really, we didn't add 4. We added 4 times negative a half. So what's 4 times negative a half? Negative 2. So I actually subtracted 2 there. So I need to add 2. So then I get minus 2 as my final answer. How do we do there? You're getting it? Right on. Okay. Last one. Factor out a 3. So if I divide minus 3 out of the minus 9, what do I get? Plus 3x, yes? Okay, again, I will repeat. Multiply this out at this step and verify you have exactly what you started with, because that's the first step people are making mistakes in, right? Minus 3 times 3x minus 9x. Do you see that? Okay, so next step. What's half of 3? Plus 1.5. What's 1.5 squared? 2.25. But we didn't add 2.25. We actually subtracted 3 times that. So what is that? 6.75 we actually subtracted. So what do we have to do to compensate? Add 6.75. And what do we get when we combine those? Plus 4.75. What do you think? Why am I adding 6.7 minus times a plus? I actually subtracted 6.75. So I have to add it to compensate, right?